Example 1 involves negated inequalities, and in order to change the negated inequality into a normal inequality, we're going to deal with what's called the trichotomy axiom. And it's telling us if we have two real numbers, a and b, that one of these three things has to be true. Only one has to be true. All right? If we're dealing with variables representing numbers, then several of them might be true. But the first number could be bigger than the second number, the first number could be less than the second number, or the first number could equal the second number. That's it. That's all the possibilities that exist between numbers. That either the first is bigger, the first is smaller, or the first is equal to the second. All right? And based on the trichotomy axiom, we go to this page here, which is the bottom of that yellow sheet I just gave you. If an inequality is expressed as a negated inequality, and they'll look like this. Not less than or equal to. Not less than. All right? And if we assume always that either greater than or less than or equal is legal, right? That's it. That's the only ways that numbers can be related, is those three ways. And this example tells us that x, what we're looking at here, is not less than, so it's not this, and it's not equal to, it's not that. What's left? Greater than. So this right here means the same as that x is greater than 5. Similarly, this other one, again, looking at our three options, we have option 1 greater, option 2 less, option 3 equal. This says x is not less than 6. So it's not this one. What's left over?
Greater than or equal to.
X must be greater than or equal to 6. So whatever's negated, whatever's thrown out, whatever's left over is what it actually is. So if it's not less than, it's not this one, it must be these two. That's how we write greater than or equal to. If it's not these two, it must be that one. All right, and every time we deal with this, that's how you want to deal with negated inequality. Priority 1, when you see negated inequality in a problem, is to change it to a regular inequality. That's it. Don't even do anything else before you do that. Immediately go to that step. So, draw a number line, graph the solution of x is not less than 2. So again, our choices are greater than, less than, equal. This says not less than. So that means x must be either greater than or equal to 2. So translate what x is not less than 2 really means. Then we graph x is greater than or equal to the same way we have already since lesson 36 or 7. Greater than or equal to 2 means at 2 I'm going to put a solid filled in circle. The equals 2 makes the 2 itself part of the answer. And then greater than 2 would be numbers like 3, 4, 5. So I'm going to shade off this direction. Make my arrow much bolder than the other arrow. You do want arrows going both directions. You want a bunch of dashes, at least 5. You want the number you care about, which is 2, on your number line, and every dash has a number on it to make a good number line. And again, scribble like this to show shading. Don't just make the line a lot bolder. That's harder to see. So make sure it's very obvious which direction you're going so I can read your graph easily.